Okay, wasn't sure what to work on today, so I thought I would do an integral. We've got something here from the MIT Integration Bee 2016. This one was number 8. We have the integral from 50 to 100 of the floor of log base 2 of x dx. Okay, to get started with this, of course, what I want to deal with here is just the floor function. The floor function is going to round us down to the next highest integer, so it's always going to return an integer. The problem we have is with these bounds here, like if you plug in a 50 here, like log base 2 of 50 is gonna be like, I don't know, like 5.6 or something. Well, the floor is just gonna round us down to 5. But then up at 100, it's gonna be somewhere over 6 and the floor is gonna round us down to 6. Basically with the bounds the way they are right now, we're not able to evaluate this to a single value. So what I wanna do here is I actually wanna break up this integral, and that's where we're gonna get the simplification. So with log base 2, we can look at things with base 2 and try to find a value here to break this up. I'll start with 2 to the 5 we know to be, this is just 32. 2 to the 6 is going to be 64, so that's going to be between 50 and 100. But at 2 to the 7th, we're up at 128. So I think what we can do is use this middle value here as our way to split up this integral, because when we plug this in, if this right here is going to be our x value, and we have log base 2 of 2 to the 6, or 64, this value is just going to be 6. And so what I can do to break this up is our first integral, we'll start with our lower bound, go from 50 to 2 to the 6, which is the same thing as 64. And when we do that, because we know that log base 2 of x is going to be 6 at the upper bound, at 50 it's going to be like 5.5 or something. The floor is going to round us down for all these values down to 5. And then for the next one, we'll have our lower bound starting at 2 to the 6 or 64, going all the way to 100. All the values here are going to be between 6 and 7. We don't get to 7 until you get up to 128, which is greater than 100. So everything here, the floor is going to round us down to 6. But now both these values are constants. We can bring them out front of the integral, and it's just going to be easy to integrate. So we'll integrate this. We're going to have for the first one, we're going to have 5x evaluated from 50 to 64. And then for the second one, we're going to have 6x evaluated from 64 to 100. Plug everything in. Over here, we're going to have a 5, and evaluating this, we're going to have 64 minus 50. And then for this one, we're going to have 6. Plug in here, we're going to have 100 minus 64. 64 minus 50 is 14 times 5 is going to be 70. Here, we're going to have 6. Difference here is going to be 36. This here is the same thing as 6 cubed. 216 plus 70 gives me my final solution of just 286. Okay, there you have it. Quick and easy one from MIT 2016. Thanks everyone for watching. Have a good day.